Next, I'm going to cover two different ways to evaluate polynomial expressions at given values for the independent variable. The first function that I'm going to cover is 3x cubed minus 2x squared plus 5x minus 1. I want to evaluate the polynomial when x equals 4, or in other words, I want to find the y-coordinate when x equals 4 if I were to graph it. So the first way you were taught to do this is substitute an x in, 4 in everywhere there's an x. So that's what I'm going to do. I get 3 times 4 cubed minus 2 times 4 squared plus 5 times 4 minus 1. 4 cubed is 64. 64 times 3 is 192. 4 squared is 16. 16 times negative 2 is negative 32. 5 times 4 is 20. Minus 1. 192 minus 32 is 160. Plus 20 is 180. Minus 1 is 179. You can see as our polynomials get larger and larger and our coefficients of the variables get higher and higher, this set of operations can become difficult, and not necessarily difficult, but can take more time in order to do. So I'm going to show you a second way to evaluate the function, and it is called synthetic substitution. So I'm going to take the same polynomial and do synthetic substitution with it. And we have 4 steps that we do to do synthetic substitution. The first step is we write our coefficients in descending order. And step 2 kind of goes with it. It says fill in zeros for missing terms. So what I mean for missing terms, if it starts out like x cubed, if this x squared wasn't here, I would put a 0 in for x squared. So for this first example, I'm going to write down a 3, a negative 2, a 5, and a negative 1. Put a little box around it. I'm going to copy the first term out here, or copy what I'm evaluating. Now my repeated steps. Copy the first term. And then this step 4, you're just going to keep on repeating. Multiply, add, multiply, add, multiply, add. You multiply the number that's here times what's out in front. 3 times 4 is 12. And then you add vertically. 12 minus 2 is 10. 4 times 10 is 40. 4 plus 5 is 45. 4 times 45 is 180. 180 minus 1 is 179. Notice that I got the exact same answer doing it both ways, either direct substitution or synthetic substitution. I'm going to do one more example of synthetic substitution so that you can see another example. In this case, I want to evaluate x to the 4th minus 10x squared plus minus 2x plus 4, and I want to evaluate this when f of x, when x is negative 3. So I'm going to follow my steps. Write the coefficients in descending order, putting zeros in for the missing terms. Notice I am missing the cubed term, so I have to put a 0 in there. So I'm going to write down the 1 for this term, the 0 for the cubed term, negative 10, negative 2, and a positive 4. I am evaluating when x equals negative 3, so I put the negative 3 out here. I copy the first term. I multiply. Negative 3 times 1 is negative 3. I add. 0 minus 3 is negative 3. Multiply. Negative 3 times negative 3 is 9. Negative 10 plus 9 is negative 1. Multiply. Negative 1 times negative 3 is positive 3. Negative 2 plus 3 is 1. 1 times negative 3 is negative 3. 4 minus 3 is 1. So if I put a negative 3 into this function, the result is going to be a 1.